My name is Reuven Edri and I'm a postdoc at Professor Tal Dvir lab, and I'm doing research about the tissue engineering of different tissue implants of cardiac cells and different neuronal cells. And I did my PhD also in Tel-Aviv University at the lab. Worked a lot about neural development of human systems, also about human embryonic stem cells. And now I'm moving to New York for an additional postdoc. Okay, so during my PhD I did a lot of research about the neural development and different stages of the human development of the neural nervous system. We mimicked the different stages that the embryonic stem cells go through until the final differentiation into neural cells. And we did a lot of culture work and with different media and different differentiations. And nowadays I moved to work about tissue engineering, and I also do a lot of different differentiations of different cell lines, mostly iPS cells and just pluripotent stem cells, and that's it. So as I mentioned, I'm working currently on tissue engineering. We try to do different mouse models to treat different injuries such as spinal cord injury or myoinfarction injuries and even Parkinson's disease. We form different tissue implants of dopaminergic neurons or spinal cord neurons or cardiac cells, and then we inject those implants to treat the different illnesses of those injuries. Human stem cells and embryonic stem cells especially, they're not like any other cell culture that you grow in the lab. And they are very spoiled, and they need very high attention. So when you grow those, you need to take care that they don't differentiate spontaneously in the lab, in the dish, and you need to focus a lot of energy to understand how the cells behave and how they grow. And a lot of challenges is actually to keep your hand on the pulse, what you say, to make sure that the cells continue to proliferate and continue to keep their pluripotency and not differentiate, and also to make sure that you can later on do whatever you want to do with them in a robust way. It really depends on what you want to do with those cells. If you want to differentiate those into different neural lineages or different mesodermal lineages, there are a lot of differences. So it's also a lot of how to change the confluence of the cultures. You need different concentrations of cells, and you need to add a lot of different ingredients, even when you want to prepare the cells into a very good differentiation. So there's a lot of interplay between the media, the time that you add the media, the splitting of the cells that you do, and the concentrations and other stuff. I started using NutriStem when I moved to this postdoc at Tal Dvir lab, because actually we want to make a system without feeder layers, without the maps that the human embryonic stem cell usually grow on. And NutriStem was actually one of the best choices for us because it gives you a great value for money, and it gives you a very robust experiment because you can repeat it with different cell lines and still get the result that you want later on during differentiation. So we use the NutriStem system and the iPS system that we have in our lab, for example, to create different cardiac patches and cardiac cells from those iPS cells that were derived from a patient. And then we could combine those with ECM from the patient to form completely autologous patches or even bigger tissues such as printed cardiac hearts. However, those are still not functional, but there is a promise for those kind of research in the future.